Okay, well, to me, this looks an awful lot like some sort of trig function. Let's see, so when I'm at 0 degrees, I have my maximum value of the function, so to me that looks like a cosine graph. So what else do we know that varies with the cosine of the angle? Well, do you remember when we did the free body diagram of a block on an inclined plane? And what was the normal force? Do you remember that it was mg cosine theta? Well, let's think about this. Let's just plug it into Excel and see what Excel spits out. So I'm going to calculate the normal force. All right, and that's going to equal the mass of the block, which is 0.0945 times g, which is, let's call it 10 for consistency's sake, and then times the cosine, okay, well, actually, I want the absolute value of the cosine because once I get past that 90 degrees, all right, I'll end up with a negative cosine, but I want to keep it positive for the sake of the graph. So I want the absolute value of the cosine of my angle. However, Excel thinks that these degrees are in radians. So that's just how it's programmed. So I have to convert, all right, my degrees from the horizontal, all right, I want to multiply that times 2 pi radians, so 2 pi is 6.28, and then that's for every 360 degrees. So I'll do that, close that other parentheses, and there we go. Makes sense that when I am on a horizontal, my normal force is just mass times g. Fill that down, and there we go. Alrighty, so let's now graph this with both of these, and we will do a scatter plot again. So now the orange one is the normal force, and the force due to friction is in blue. And the orange one now looks an awful lot like that blue one did before. So this doesn't have a title, so let's call this normal force and friction force, all right, versus angle. So to me, that looks an awful lot like those are both related to the cosine of the angle.